wonder why a balloon suddenly pops on a sunny day? Or why your car tire seems underinflated on a cold morning? These everyday phenomena are governed by gas laws, the fundamental principles that explain the behavior of gases under changing pressure, temperature, and volume. Let's dig right in. The standard temperature and pressure provides us a reference point for comparing behaviors of gases. There are four variables: P for pressure, V for volume, T for temperature, and N for moles of gas. It's very important to know the unit and the value at STP because sometimes yung problem sasabihin nila lang at STP without providing the values. So very important for you to remember the unit and the value. So pressure at STP is 1 atmosphere, volume is at 22.4 liters, temperature is at 273 Kelvin, and N or moles of gas is at 1 mole of gas. Boyle's law tells us that when we reduce the volume of gas, the particles collide more frequently and so the pressure increases, given that the temperature remains constant. So this means that pressure and volume are inversely proportional. When pressure increases, volume decreases and vice versa. So what's an example of this? When we inhale, our lungs expand and pressure decreases. Air is able to move in. But when we exhale, our lungs deflate or decrease in volume and thus the pressure increases, pushing the air out of our lungs. Let's take a look at the practice problem. Sabi dito, a gas occupies a volume of 5 liters at a pressure of 2 atmosphere. Ano daw yung volume of gas if the pressure is increased to 6 atmosphere, assuming a constant temperature? So how do we know anong gas law yung gagamitin? We'll look at what is constant. For this problem, sabi niya, constant daw yung temperature. And if temperature is constant, we use Boyle's law. Boyle's law is P1, V1 is equal to P2, V2. Tamang-tama because for this case, we're looking at our V2. So we just plug and place since we've already identified our values for V1, for P1, and for P2. So P1 is 2 atmosphere times our V1, which is 5 liter. P2 is at 6 atmosphere times our V2, which is what we're looking for. So just solve this equation. The transpose lang natin. So that's V2 is gonna be equal to 2 atm or 2 atmosphere times 5 liter all over 6 atmosphere. So our answer is 5 over 3 or that is 1.67 liter. Charles' law explains to us how hot air balloons rise. When the air is heated up, its volume expands. Thus, its density decreases compared to its surrounding cooler air. This allows the hot air balloon to rise up above the sky. So ano nga ba yung Charles' law? Charles' law states that volume is directly proportional to temperature in Kelvin considering that our pressure is constant. So this is the equation for Charles' law. Let's look at a practice problem. Sabi dito, a sample of gas occupies 5 liters at negative 23 degrees Celsius. This gas is heated to 327 degrees Celsius while maintaining a constant pressure. Ano daw ba yung final volume natin? Since our pressure is constant, we will be using the Charles' law. For this problem, it's very important to note na dapat yung gagamitin natin na temperature is at Kelvin. So we have to convert yung Celsius to Kelvin. So to convert Celsius to Kelvin, we actually just add 273 to the Celsius that we have. So this will give us 273 minus 23, that's gonna give us 250 Kelvin, and 327 plus 273, that's gonna give us 600 Kelvin. So we know that Charles' law is just V1 over T1 is equal to V2 over T2. Let's just plug and play. That's gonna be 5 over 250 is equal to the V2, which we are looking for, over 600. So let's just transpose to get V2 is equal to 5 times 600 over 250. And that is going to be equal to 12. Gay-Lussac's law states that when pressure is directly proportional to temperature in Kelvin, considering that our volume is constant. This means that when pressure increases, our temperature also increases. For example, a sealed pressure cooker heats up, causing the pressure inside to increase. Let's take a practice problem. Sabi dito, a sealed gas container has an initial pressure of 3 atmosphere at temperature of 400 Kelvin. The container is heated to 600 Kelvin. So our temperature 2 is 600 Kelvin. What is the final pressure inside our container? So for this one, we will use the Gay-Lussac's law, since this involves the pressure and the temperature. So Gay-Lussac's law states that P1 over T1 is equal to P2 over T2. So let's just plug and play. So that's 3 atm or 3 atmosphere over 400 Kelvin is equal to P2 over 600 Kelvin. P2 is just 600 Kelvin times 3 atm or atmosphere over 400 Kelvin. And that gives us final pressure of 4.5 atmosphere. Avogadro's law states that volume is directly proportional to the number of gas moles, meaning the more gas moles or the more number of particles of gas present in an environment, the higher the volume of that environment is. Considering that our pressure and our temperature remains constant. For example, when we add more gas, it increases the volume of a balloon. Let's take a practice problem. Sabi dito, a gas occupies 10 liter with 2 moles of gas. If 3 moles of the same gas is added, what will be the volume at constant temperature and pressure? So ano ba yung variables natin? First, we have volume 1, which is at 10 liters. And we have also our N1, which is at 2 moles of gas. If 3 moles of the same gas is added daw, ano daw yung final volume? So meaning we are looking for our V2, our final volume. Now, ano ba yung N2 natin or our second amount of gas, moles of gas? Dito, take note that sabi niya, 3 moles were added. Hindi 3 moles yung N2 mo. It's 3 plus 2 because you add 3 to the initial amount of gas. And that gives us 5 moles. So let's just plug and play. Our formula is going to be V1 over N1 is equal to V2 over N2. And that's going to be 10 liters over 2 moles is equal to V2, which is what we're looking for, over 5 moles. So we'll just transpose to get V2 is equal to 10 liters times 5 moles over 2 moles. And that's going to be 25 liters. The combined gas law relates the pressure, volume, and temperature when N is constant in one equation. This is the equation of the combined gas law. For example, when we want to predict gas behavior that has changes in pressure, in volume, and temperature conditions, then we use the combined gas law. In this practice problem, sabi niya, a gas has an initial pressure daw of 2 atm, a volume of 4 liters, and a temperature of 250 Kelvin. Sabi niya, if the temperature daw is increased to 500 Kelvin, and the volume is reduced to 2 liters, ano daw yung final pressure natin? So since we're dealing with pressure, volume, and temperature, we'll be using the combined gas law, which is basically P1 V1 over T1 is equal to P2 V2 over T2. So let's just plug and play. 2 times 4 over 250 is equal to what we're looking for, yung P2 times 2 over 500. So let's just transpose. So we get P2 is equal to 2 times 4 times 500 all over 250 times 2. This gives us P2 is equal to 8. The ideal gas equation combines Boyle's law, Charles' law, and Avogadro's law into one equation to help us solve complex gas problems. It's very important for us to remember our ideal gas constant R. The ideal gas constant R is 0.0821 liter times atmosphere all over moles times Kelvin. The same units must be used for other variables when solving this equation. Let's look at a practice problem. Sabi dito, a 5-liter tank contains 0.5 moles at 77 degrees Celsius. What is the pressure inside the tank? So we're looking for pressure. As we have said earlier, dapat yung temperature natin naka-Kelvin. So let's convert Celsius to Kelvin. So 77 degrees Celsius is just 350 Kelvin. So for this problem, we will be using the ideal gas law, which is PV is equals to nRT. Remember that our R, ideal gas constant, is equal to 0.0821 liter times atmosphere over mole times Kelvin. So let's just plug and play. P is equals to nRT over V. That's gonna be equal to 0.5 times 0.0821 times 350 all over 5. That is equal to 2.87 atmosphere. And that's it for this video. Let's just run through our key points. Again, Boyle's law is pressure and volume are inversely related. Charles' law, volume and temperature are directly related. Avogadro's law, volume and our moles are directly related. And our combined gas law and ideal gas equations summarizes all these relationships. If you have any comments, suggestions, or questions, just type them down below and we will get back at you. I'm Ami. Like and subscribe for more videos. Yay!